Another example, we will see how to write the balanced chemical equation. Aluminium reacts with chlorine to give aluminium chloride. So how to write the skeletal equation? Aluminium being a metal, its symbol should be used in the equation. So Al plus, chlorine is a diatomic molecule, so we write it as Cl2. So Al plus Cl2 gives, the product formed is aluminium chloride, the formula of which is AlCl3. Now always when we write the skeletal equation, we should be very careful that we write the correct formula of the compound formed. If you make any mistake in writing the skeletal equation, you will not be able to get the balanced reaction equation, balanced equation. So always when you write the skeletal equation, you should be very thorough with the formula of the compounds. So say the number of atoms of aluminium and chlorine on both sides of this skeletal equation which you have written. Aluminium, 1 atom is present on both sides, whereas chlorine, 2 atoms present on the reactant side and 3 atoms present on the product side. Since the number of atoms of chlorine is different, we will start with chlorine. On the left hand side you have 2 atoms and on the right hand side it is 3. So to balance, the 2 should be multiplied by 3 and the number 3 should be multiplied by 2, so that we get 6 on both sides of the equation. Here in this example, we are multiplying the numbers given on both left hand side and right hand side by suitable numbers, so that we get the same number on both sides of the equation. So after multiplying the left hand side by 3 and the right hand side by 2, we get the new equation as Al plus 3Cl2 gives 2AlCl3. Now check the number of atoms. Aluminium, it is 1 and 2 on the product side. 1 on the reactant side and 2 on the product side. Whereas chlorine, it will be 3 into 2, 6 atoms of chlorine on the reactant side. When you write 2AlCl3, that gives you 2 into 3, 6 atoms of chlorine. So we get 6 atoms of chlorine on both sides of the equation. But the number of atoms of aluminium is not the same. So next take aluminium. Left hand side 1 and right hand side 2. So to balance, the left hand side 1 should be multiplied by 2. The RHS 2 remains as 2 itself. Now when you multiply 1 by 2, we get the new equation as 2Al plus 3Cl2 gives 2AlCl3. Now again check the number of atoms of aluminium and chlorine. In the case of aluminium, it is 2 on both sides of the equation. So the number has become same. Now take chlorine 3 into 2, 6 atoms of chlorine, and from 2AlCl3 you get 2 into 3, 6 atoms of chlorine. So 2 atoms of aluminium on both sides of the equation and 6 atoms of chlorine on both sides of the equation. The equation is now balanced. Another example. This you can try to work out. Check it, do it yourself and check the answer. The reaction is aluminium plus copper chloride gives aluminium chloride plus copper. Start with the skeletal equation. Aluminium being a metal, we write it as Al. Copper chloride is cupric chloride. The formula is CuCl2. So Al plus CuCl2 gives aluminium chloride is AlCl3. Copper being a metal, we write it as Cu. This is the skeletal equation. Try to solve it yourself and try to get the balanced equation. See the next example. Lead nitrate reacts with potassium iodide to give lead iodide and potassium nitrate. The skeletal equation is PbNO3 twice plus Ki gives PbI2 plus KNO3. This is the skeletal equation. Now how to take the number of atoms? See, in this skeletal equation, the number of atoms of lead is 1 on both sides of the equation, and nitrogen from NO3 twice, from that part you get 2 atoms of nitrogen and 3 into 2, 6 atoms of oxygen. So that is how you have to take the number of atoms of nitrogen and oxygen. So now try to write the balanced equation. Try to solve it. What are state symbols? State symbols are used to represent the state of all the reactants and products in a chemical reaction equation. The different state symbols used are S to represent a solid, L to represent a liquid, G to represent a gas, and AQ to represent an aqueous solution. Consider the following equations. We shall see the different state symbols used in these cases. First one, hydrogen reacts with nitrogen to give ammonia. Here hydrogen is in the gaseous state, so the symbol G is used. Nitrogen is again in the gaseous state, G is used. Ammonia is a gas, the state symbol used is G. Now take the next example B, H2S. Hydrogen sulfide plus oxygen gives water H2O plus sulfur dioxide. In this particular equation, hydrogen sulfide, oxygen, sulfur dioxide all are in the gaseous state. So the state symbol used is G, whereas water is in the liquid state. Therefore the state symbol used is L for water. Now take the third case. Barium chloride plus aluminium sulfate gives aluminium chloride plus barium sulfate. In this particular reaction equation, barium chloride solution is taken. That means barium chloride crystals dissolved in water, which is known as an aqueous solution, is taken. Therefore, the state symbol of barium chloride is AQ. Similarly, aluminium sulfate and aluminium chloride, the state symbols of both these are aqueous. Barium sulfate is a precipitate formed in the reaction. Since it is a precipitate, it will be in the solid state. Therefore, the state symbol used for barium sulfate is solid S. Now, fourth one, potassium plus water gives potassium hydroxide plus hydrogen. Here potassium is a metal and it is in the solid state. Therefore, the state symbol used is S. Water is in the liquid state. Potassium hydroxide formed is in the form of a solution. It will be dissolved in water. So the state symbol used is aqueous, AQ. Hydrogen is in the gaseous state. Therefore, the state symbol used for hydrogen is G.